Welcome to the deep dive. Sometimes the most cutting-edge technology has these really surprising ancient roots. Today, we're diving into how the mind of an ancient Greek philosopher, Aristotle, actually shaped modern artificial intelligence, and crucially, where his brilliant ideas eventually, well, they kind of hit a wall, forcing us to rethink everything. We've looked into a really rich collection of sources for this deep dive, including some critical excerpts from Aristotle's Logic, Symbolic AI, and Hybrid Systems by Gerardo Iovani and Giovanni Iovani. Plus, we've pulled in insights from some foundational thinkers like Newell and Simon.
Oh yeah, key figures.
Definitely. And also Dennett, Dascal, Vernon, and Furlong, and Vadinsky. So a good mix. Our mission today is basically to take you on this journey. From ancient logic right up to today's cutting-edge AI, we want to reveal how these systems are designed to think, where they often stumble in the messy real world, and maybe what the future looks like as we push past those limits. Okay, let's get into it.
Yeah, absolutely. To really get a handle on modern AI, you really have to start with Aristotle. It's unavoidable. His work on formal logic is it's profoundly foundational. It literally provides the bedrock for deductive reasoning and computing. His syllogistic logic especially, that became the blueprint for what we now call symbolic artificial intelligence, or, good old-fashioned AI sometimes. And this deep influence, it's really perfectly captured by the physical symbol system hypothesis.
Right, that was Newell and Simon, wasn't it, back in '76?
Exactly, Newell and Simon, 1976. And essentially what they proposed was, look, if a system can just manipulate formal symbols.
Okay, like sort of perfectly defined logical tokens, little building blocks.
Precisely, think of them like that. If it can manipulate those within a structured, rule-bound digital environment, well, they argue that's actually sufficient for generalized intelligent action.
Huh. So just moving symbols around according to rules is intelligence.
That was the hypothesis. It's like saying, if you can perfectly follow the rules of chess, you're demonstrating chess intelligence. It fundamentally shows how Aristotle's logic, that kind of structured reasoning, made its way into computation.
Okay, so when we talk about this symbol manipulation becoming AI, it still sounds a little abstract, maybe. What does it actually look like in practice? How does that kind of system really, work in the world?
That's a great question. So in symbolic AI, it means you're explicitly encoding logical operators, A and D, or not T, things like that, and inference rules. You're basically building a very precise, very vast rule book inside the computer.
Like programming in pure logic.
Pretty much. A classic example, one of the early ones, was AIMICIN, an expert system. It used this kind of logic for large-scale data processing, specifically in medical diagnosis.
Right, I've heard of that.
Yeah, and you also see these systems used heavily in, say, legal domains, banking, anywhere where compliance with very specific, well-defined regulations is absolutely critical. And the core benefits, well, they're pretty clear. You get astonishing precision, and you get complete transparency.
Transparency? How so?
Because these systems can literally trace back exactly how they reached a conclusion, step by logical step. They can provide a clear, logical reason for every single output, which is invaluable if you need to show, say, evidence of compliance.
Ah, okay. Like an audit trail for the AI's thinking.
Exactly. And philosophically, symbolic AI directly mirrors Aristotle's whole project, his desire to categorize the world into these rigid, defined forms, genus and species, that kind of thing, all to create explicit knowledge and allow for clear, undeniable inference within those structures.
So, okay, on paper, that symbolic AI approach, it sounds almost like the Holy Grail, right? Perfect logic, total transparency. But as we often find, perfect in the lab doesn't always mean robust out in the wild. Which brings us to the big question. Where does this beautiful Aristotelian system start to fray when it hits real-world complexity?
And that's exactly where the, let's call them, philosophical vulnerabilities really start to show up.
Yeah.
Especially when these systems step outside their perfectly controlled, defined spaces. Like Vernon and Furlong pointed out, the absolute requirement for explicit specifications.
Meaning everything has to be spelled out perfectly beforehand.
Precisely. Every possibility, every rule. That need for total clarity can severely restrict how widely applicable these pure systems are and how well they scale up. They tend to be incredibly brittle, fragile when they face incomplete or ambiguous data. Yeah. They just fundamentally struggle with all the vagueness, the instability, the ambiguity, the constant change, all the stuff that's totally normal in real-world situations.
Because the real world doesn't fit neatly into predefined boxes.
It's not at all. Pure symbolic systems demand that their inputs conform exactly to their internal models. If the input is slightly off or unexpected, the system can just break down. or, fail to work properly.
And this really leads us to a very vivid illustration of these limitations, something called the frame problem.
Yeah.
Daniel Dennett wrote about this famously back in '87, and it just hammers this point home, doesn't it?
It really does. Dennett, he argued that after any action or change, these formal systems, in principle, have to reconsider everything relevant within their knowledge base. Everything potentially relevant. But here's the massive issue. They have no built-in, common-sense way to know what's actually relevant or important in that moment. They lack a sense of priority. He used this thought experiment, the R1D1 robot, which is quite famous.
Tell us about it.
Okay, so R1D1 is tasked with fetching its spare battery from a room. But, there's also a bomb in the room, sitting on the wagon with the battery. The robot knows pulling the wagon out will bring the bomb out too. Fine. R1D1R, the smarter version, knows removing the bomb first is key. But it sits there thinking, does moving the bomb affect the paint color? Does it violate warranty? It calculates endless irrelevant consequences.
While the bomb is ticking.
Exactly. It gets paralyzed by trying to update all knowledge, failing to prioritize the immediate critical danger. Dennett used this to show a deep epistemological problem. These formal systems just struggle terribly with figuring out relevance and significance in dynamic, real-time situations. It reveals a lack of real competence, not just calculation power.
Wow. So the robot, designed for perfect logic, essentially gets completely bogged down. It's paralyzed by possibility. It's like trying to alphabetize your spice rack while the kitchen is on fire. You can't prioritize what actually matters most right now.
That's a great analogy. It really highlights how abstract logic just bumps hard against real-world urgency and, well, chaos. Precisely. And it's not just Dennett pointing this out. You have thinkers like Dascal arguing that these Aristotelian ways of knowing, these epistemologies, they're fundamentally inadequate for robust AI. Why? Because they're too static, too formal. They simply can't cope with the inherent uncertainty, the constant flux, the time-varying nature of sensory input from the real world.
It's always changing.
Always. And Vadinsky builds on this, saying symbolic AI really struggles to incorporate fine-grained sensory data. Subtle cues we pick up all the time and generalize its significance effectively in the moment.
Okay, so if Aristotle's logic, which is clearly foundational, struggles so much with the messy modern world, does that mean we just, throw it out? Is it totally irrelevant now, or is there a way forward that still uses its strengths?
Oh, definitely not throw it out. No, this situation absolutely calls for something called epistemic pluralism.
Okay, fancy term. What does that mean in practice?
It's basically saying we need to stop thinking there's only one right way for an AI to know or reason about the world. Instead, we need to embrace the necessity for hybrid models that combine different approaches to knowledge and reasoning.
So mixing and matching.
Exactly. This approach intelligently bridges that precise symbolic reasoning, the Aristotelian part, with other methods that allow for context-dependent adaptation, learning from experience, essentially. So what happens in these hybrid architectures is you combine modules. Some are designed for that precise, explicit symbol manipulation we talked about.
The logic engine part.
Right. But you combine those with other modules that can operate more implicitly. They can derive significant relationships directly from raw sensory data, from patterns, from experience.
Okay, that sounds promising. Can you give us a concrete example? A system that actually does this kind of blending. It helps to picture it.
Absolutely. Ron Sun's Clarion architecture is a really good example here. It explicitly contains symbolic representations, those clear rules and facts, much like the older systems. But, and this is crucial, it can adapt its symbolic processing. It learns over time based on experience.
So the rules aren't completely fixed.
Exactly. It's not just following fixed rules blindly. It's learning how and when to apply those rules, maybe even adjusting them based on new incoming sensory information or feedback. And this is where the strength of non-symbolic approaches, often called connectionist methods like neural networks, really shines within these hybrid systems.
Okay.
Their big advantage is their capacity to adapt to changing sensory info. They can function pretty well even with ambiguous or incomplete data, which means they can cope much better with the inherent uncertainty of the physical world, the very thing that trips up the purely symbolic systems. So ultimately, this hybridization, this blending, it allows systems with formal computation engines to deal with uncertain and incomplete sensory data far more comprehensively.
It sort of patches the holes.
It directly addresses those deficiencies highlighted by the frame problem, yes. And it strongly suggests we really have to abandon the dream of a purely, strictly logically oriented AI if we want robust, real-world intelligence. And what's just fascinating, truly mind-blowing here, is that Aristotle, this thinker from millennia ago, still provides a core blueprint for AI design. But his very framework, his very brilliance, also reveals AI's Achilles heel. It forces us towards these more flexible, more adaptable hybrid paths to try and achieve something like true intelligence.
Wow, what an incredible journey we've really taken today. From the foundational brilliance, really, of Aristotle's ancient logic, we moved through the precise, yes, but ultimately limited world of pure symbolic AI, and now we've landed in this really exciting space, the possibilities of hybrid systems. These new systems seem to blend the best of that deductive, logical reasoning with the absolutely essential ability to adapt to real-world messiness, real-world complexities. So you've seen how these centuries-old philosophical ideas are still actively shaping our most advanced technologies today. And just as importantly, how recognizing their inherent limitations is precisely what drives innovation forward. It forces us to get creative. For you, the listener, this deep dive hopefully highlights a really crucial point. Intelligence, whether we're talking human or artificial, it probably isn't a single rigid process. It seems much more likely to be a flexible combination, a dance between different ways of knowing and interpreting the world around us. We saw how that frame problem, that robot stuck thinking, really pushes us to think beyond just strict rules and fixed categories. And this raises, I think, an important question for all of us to maybe mull over. In what other areas of our own lives might we be unknowingly relying on rigid frameworks, on fixed ways of thinking that actually struggle to adapt to the fluid, unpredictable reality that's constantly unfolding around us? Something to think about until next time.